Hello friends, welcome to Coding Garden. Welcome to Advent of Code 2023 Day 2. In this video, you're going to see me attempt to solve the Day 2 problem. Spoiler, which you can probably already tell by the length of this video, it's actually much easier than yesterday. But yeah, in this video, I solved parts 1 and parts 2. If you are solving it and working on Advent of Code, definitely leave a comment. Let me know how you solved it if you did it differently. And enjoy the video. Day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. An elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. To get information once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like the 11 in game 11, colon, followed by a semicolon, separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this: 3 blue, 4 red, 1 red, 2 green, 6 blue, 2 green, etc. for game 1, game 2, etc. So this is just explaining what's happening here. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green cubes, and 14 blue cubes. In the example above, games 1, 2, and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. Similarly, game 4 would have also been impossible because the elf showed you 15 blue cubes, and there are only at most 14 blue cubes. If you add up the IDs of the games that would have been possible, you get 8. Determine which games would have been possible. Okay, so I think to summarize what needs to happen here is we need to parse each line to determine how many of each color were drawn for each game, and compare that with the maximum amount of each. And if any one of them is over their corresponding maximum amount, that's an invalid game. That is the problem we are solving. Let's go. So I've got a day 2 folder in here. I'm going to create an example input file. We're going to throw this in here. I'm going to copy my code from day 1, which does the reading. I probably could create like a utils file at this point, but I'm not going to right now. So read in that example file. And so if we call, let's just say log part 1 with example.txt, that's going to run this function, read in all of the lines, and then we can do something with the line. And essentially what we need to do right here is for every line, we need to parse it. So we're going to be looking at a line that looks like, let's just say we grab the first one as an example. We need to parse this line. So if we first separate it on a colon, that's and grab the right-hand side, then we can separate that by semicolons to get each game, like each draw, and then we'll further parse it from there. So for the given line, I'm going to say split it on a colon space, and then grab the one to the right. And so that should grab the right-hand side. I guess do we call these turns? Because these are like turns in the game. Sets. Let's call these sets. So these are all of the sets. And if we further split that on semicolon space, we're going to have each of the sets, and then for each of those, we could map it. That's going to give us the individual set as a string, and then we'll split that on comma space, and that will give us each one. I'm just going to log this out to see if I've done anything weird, and let's see what we got. So for game 1, game 2, game 3. So all of our parsing, I think, looks good. Let's compare it really quick. 3 blue, 4 red, semicolon. 1 red, 2 green, 6 blue, semicolon, 2 green. Yeah, okay, so our parsing so far is good. And then for each one of those, for each one of these, so now that we have these, we could further map over those to get like a number and a color. It looks like we can hard code the maximum number of each. So let's just create like a little map here. We'll call this like max count. And we basically want to have the color map to the maximum amount. So there are 12 red, 13 green, 14 blue. And then for each one of these sets we have, so like 3 blue, 4 red, for each of those, we need to look at the 3 and then say, okay, we need to look at blue. Is it less than that? And if it's true for all of them, then that game is valid. So here's what we're going to do. We're going to map to booleans of whether or not this specific set is valid. So this gives us the, what do we call these? Let's call these pools because we're pulling them out of the bag. So this is going to be an array that has 3 blue, 4 red inside of it. And then we want to return for each of those, is every one of them less than the max? Here, so if we say we now need to split that on a space, which is going to give us the count and the color. So if we split that, we get count and color like this. And we will want to know, is max count at that color less than or equal to the count parsed as a number? And so because we did this map here, we should now have, for game 1, we should have an array that has true or false for each of the pools to say whether or not that was a valid game. So we have false, 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 false. Okay, this is not, that didn't work. Let's make sure we're getting the right color and count. Did I do that right? Yeah, count and then color. 3 blue, 1 red, 2 green. And then max count has red, green, and blue. Did I do this wrong? No, I have this wrong. This needs to be greater than or equal to that count. There we go. There we go. Okay. So now for game 1, every play was valid. Every play was valid there. The first play was invalid for play number 3. So if we look at play number 3, this is invalid because there were 20 red. And then if we look at the second to last play, is invalid because we have 15 blue when there are only 14 maximum blue. So yeah, I think we've done it. So for every possible set, we determine whether or not it was valid. And then we need to find which one of these arrays has all true values in it, because we need to make sure that they were all valid. So we have this resulting array of arrays. And then from here, I want to return every play is true. Like that. Okay. So we should get true, true, false, false, true. So true, true, false, false, true. All right. We've done it. We've reduced it to here. Now, each one that is true, we take that game number and we have a total sum. So we're going to reduce that whole thing. We have the total sum. We have the game result, and then we have the index. I'm going to use the index as the game number. So if result is true, then we want to return sum plus I plus 1 because index is 0 based. Otherwise, we just return sum. And we start the whole thing off at 0. All right. Let's see 8. I'm surprising myself at how I'm just getting it on the first try, but that seems to work. So we get the number 8. That seems right here. Let's do it here. If we look at our puzzle input, ideally, the game number is just always increments. Yeah, the game number always increments, so we don't have to worry about anything weird like the game ID. So I think we should be good. If I run my code through this, we should be good. Let's see. And then now we're going to run this on the actual input instead of the example. We're going to hope for a first try. So 2283 is our answer. Got it. All right, now for part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it for yourself. Okay. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? I see. So, yeah, we have to look at, I think what we have to do is we have to look at the maximum, I guess I'm thinking ahead here, but I think we have to find the maximum amount of any given color for all games played. And that's going to be the minimum amount to make it possible. In game one, the game can only have been played with as few as 4 red, 2 green, 6 blue cubes, etc. So if I'm thinking about this right, in order for the entire thing to be possible, we would have needed 20 red, 15 blue, and maybe 13 green. The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. And the power of the minimum set of cubes in game 1 in 48 is 48. In games, okay, so never mind. It's not across each total game. It's across each individual. It's not across all total games. It's across each individual game. The power of the minimum set of cubes in game 1 is 48. In games 2 through 5, it was 12, 15, 60, 630, and 36. Respectively, adding up these 5 powers produces 2286. So for each game, find the minimum set of cubes that must have been present. What is the sum of the power of the sets? Okay, so now for each line, we need to find the maximum blue, maximum red, and maximum green. And then we find those values cubed. So let me make sure I have this right, because so like for line 1, it would have been the maximum blue was 6. So 6 cubed is, I don't know. I can't do math. 6 cubed is 216. Okay, the power of a set of cubes is equal to the number of red. Oh, no, you just multiply them together. Okay, never mind. So if we say there are 6 blue maximum, 2 green maximum, and 4 red maximum, we get 48. Okay, easy enough. And so that's the power of that line. And then we have to add them up. Okay. Yeah, this is way easier than yesterday. I can do this. This is easy. Okay, so I'm just going to copy my part 1 function, rename it to part 2. And then right here, where we get the count and the color, we basically want to find the maximum of any given one. And for each game, now I think I'll just do this. No, each line requires a maximum. So I think what I need to do is each line gets a max count that we just store like right here. And everything starts off as 0. And then for each game, if max count at that color is less than or equal to that number, we overwrite it in our max counts here. So then we'll just say max count at that color equals that. And we can just do less than. So if the maximum one we've come across for that color is less than the current one, overwrite it. And then at the end of it all, we should have the max counts for that line. Yeah, we don't even need to map this. We just need to for each it. For each. Because then right here, for each given line, we should have our unique max count here. This is so much easier, right? Am I crazy? Am I crazy? We'll do part 2. 4, 2, 6, 1, 3, 4, 20, 13, 6. Yeah. Yeah, I mean, let's confirm. Let's confirm that we've gotten the maxes for each one. So game 1 could have been played if there was few as 4 red, 2 green, 6 blue. All right. Game 2 would have been 1 red, 3 green, 4 blue. All right. Game 3 would have been 20 red, 13 green, 6 blue. All right. 14 red, 3 green, 15 blue, 6, 3. Yeah. It's too easy. Okay, so now if we do want to, for any given line, we just need to return red times green times blue. So we've got 48, 12, 15, 60, 630, and 36. That's right. And then we just reduce it. We sum it? Yeah, we sum it. 2286. 2286. You know, now I'm actually mad at how hard yesterday was compared to this. I mean, I don't know. This was so much easier than yesterday. Done. All right. I'm crushing it now that I can do what I want. But yeah, we did it. And I guess I was like at max 20 minutes. GG's, everyone. GG's. My favorite Advent of Code puzzle so far? You mean like in the history of Advent of Code? I mean, I can't remember the years, but there was one, yeah, including past. Maybe it was the first year I did it back in 2019. You were basically building a computer, like you were building like you're building like a memory interpreter, almost like a compiler or something like that. Was this the one? Yeah, you have opcodes. Yeah. This one was super fun. As you can see, like I haven't really gotten past like day 8 or so. I lose steam. I get busy in the month of December. Like I can't wake up at I can't stay awake till midnight anymore. Thanks for dropping in, Eric. Your name looks really familiar. Have I seen you here before? But yeah, this one was super fun. Oh, okay. I didn't want to assume, but I was like, yeah, all right. The literal creator of Advent of Code. Thank you for being here. I appreciate you. That's awesome. So I mean, I'm curious. So now that I have you here, Eric, I'm actually really curious about yesterday's problem. I mean, I guess you heard me kind of talking about it. Like, so many people had an issue with part 2 of yesterday. Did you do it on purpose? Because I kind of thought, I was like, all right, maybe it was devilish. Maybe they did it to kind of weed people out or to prevent people from like using AI to solve the problems. Or maybe the play testers just didn't think it was as hard as everyone else thought it was. I don't know. Because regular expressions are probably one of the things that I need most work with. Like, there's so much I don't know about regular expressions. I ended up solving it with one, but I know for a lot of beginners, regular expressions are pretty tricky. Part 2 wasn't deliberately difficult. I have non-technical beta testers. Yeah, fascinating. Because it's like, I mean, maybe it's just the kind of coders that I'm seeing. But like, yeah, the people in my chat, the people in my Discord and my YouTube comments, and then I was watching the Primogen solve it this morning. And so many people in the chat were complaining about. Yeah, I feel like they overthought it. I think the thing that really caught people up was like the combination of the words, but I didn't run into that. I don't know if you saw how I solved it yesterday. It was the most convoluted thing ever. So I had one piece of code that found the first occurrence from the left, and that was just like a pretty general, easy regular expression. And then I literally reversed the input and reversed my regular expression to find the first one from the end. So I didn't run into the issue where like people were replacing 2 and then they missed the 1. So I kind of got lucky with how convoluted my solution was. My favorite is the people who did a replacement. Oh yeah, so I was thinking of so the overlaps work. Well, what I was thinking of is like if I would have solved it that way, I think I would have come up with every combination of number words smacked together, and then just put that into my regular expression, right? So 21 becomes 21 in my regular expression replacer, and then that replacer comes before the 2 or the 1 replacer. I think that's how I would have done it if I did it that way. Buddy's Pizza says, I finished the problem a few minutes ago, and honestly, I'm a little upset that the global leaderboard only cares about the first 100 people to solve the problems. Any suggestions on how I can ask the devs for a bigger leaderboard? Just join a private leaderboard. I mean, that's what I do. Like, I already know that I can't compete. Where is it here? I can't compete with the top 100 people. Like, there's no way. Like, a lot of the people that are in the top 100 do these kinds of things on a daily basis. So it's almost like their job, and they've solved previous years, and they have like little helper libraries ready to go for like common tasks so they don't have to write it from scratch. Like yesterday, there was a lot of like reversing of strings. I didn't even write a helper function. I manually reversed it every single time. I guarantee you most of the people in the top 100 have like a helper utils library that the moment they need to do something, they don't even have to write the extra code to do it. So yeah, I would say don't compete on this leaderboard. Join a private leaderboard. So we have the Coding Garden leaderboard here, and I mean it's my own leaderboard, but I'm in 5th place. I'm happy with that. But basically, there's a private leaderboard code, and then anybody that wants to join my leaderboard can. And then we just compete with each other. So I prefer to compete with people that are more at my level than like the top 100 in the world. So I'm sure if you search around for other coding communities, I'm sure that they have leaderboards that you can try to participate on. Also, like if you maybe if you're in school or something like that, you can create a leaderboard for you and your classmates, and then just compete against them. Or spend all your practicing and become a competitive coder to get in the top 100. Buddy's Pizza says they're number 4 on mine. Let's see. Nice. Eric says, I was just on a podcast where I talk a bunch about how different the skill set is for competition programming versus software engineering. Yeah, I'll take a listen to that, because, I mean, I think that's the other interesting thing about our industry as well, is like for people that are searching for jobs, there's such a huge focus on leak code, which is similar to this, right? It's like isolated problems where you're either trying to do them really fast or you care a ton about like performance or memory. And that's so different from like building software. It uses the same skills in a way because you're problem solving and things like that. But to be this good is a completely different set of skills than to be like a really good senior software engineer employed at a big company. The skills can overlap, and I do think some of the people at the top of the leaderboard are also good software engineers, but it's a separate skill set for sure. Hello again. Thanks for watching. Hopefully you enjoyed this, and we'll see you in the next one.